You guys remember this equation from our Desmos activity? It looks like we have almost like a parabola here, right? And if you were to solve this differential equation by separating your variables and integrating, you got this, right? And then you used the ordered pair that we were given to find a particular solution. And most of you ended up with this. And what I meant to put there was the plus 1, because you got c equals 1 and you got plus 1. And then you type that into Desmos. And I've made all of your names anonymous, but you can see that for the most part, you guys got the same thing that I got right here. Some of you left off the absolute value around your y, and just a few of you got something completely different, so not sure where these came from. But for the most part, we all got the same thing, which is very interesting. Now, on this screen, you can see that nobody solved for y. We just took that equation and we typed it into the next screen. Where we ended up, for the most part, with the combination of these two graphs. We had a few random graphs here and there, but for the most part, everybody got a combination of two different functions. And notice that it's not one function because it fails the vertical line test at pretty much every point. So, two different functions, y equals something, and y equals the negative something, because they're basically mirror images of each other over the x-axis. So this is what we get when we graph the natural log of the absolute value of y equals x squared plus 3x plus 1. So this or any of the others like it. Now, if we were to solve for y in this equation, we end up here, and a lot of people think that this equation is exactly the same as this one. All right, but if we graph this equation, we would not get two different parts of the function reflected over this. If we graphed this equation, we would get just the top branch of this. So e raised to the x squared plus 3x plus 1 is just this top part. The bottom comes from the negative version of that. Negative e to the x squared plus 3x plus 1. So for that reason, and also for an algebraic reason that I'm going to show you in just a second, we need a plus or minus on this function. Here's the other reason in a little thought bubble down here. If you had an equation, absolute value of y equals 2, what possible values could we substitute in for y here so that when we evaluate the absolute value, we get 2? You think for just a little while, you realize that y could be positive 2 or it could be negative 2. So y equals plus or minus 2. Notice that I went from absolute value of y to positive y over here, and over here I went from 2 to plus or minus 2. Just like here, I went from e to the x squared plus 3x plus 1 to plus or minus e to the x squared plus 3x plus 1. So I wanted to point that out to you so that you would see why we put the plus or minus. However, in order to find one function, because according to textbook, I'll pull that up, and this is actually a guy named Larry Riddle, who was the head grader for the 2006 AP test. He's quoting a textbook in which they say that a solution is a continuously differentiable function that satisfies the differential equation on an interval. So what we have here is not a function. because when we graph it, like we mentioned, it doesn't pass the vertical line test. However, if we remove one of those two branches, we do have a function. So which branch do we need to remove in order for this to go through the ordered pair 0, comma e, like we talked about in the original question over here? So if we want it to go through 0, comma e, we need the upper branch, not the lower branch, as you saw when you graphed it on Desmos. We just want the upper branch, not the lower branch. So we get rid of the plus minus, and we keep only the plus version of this. So ultimately, this is our final solution. So if you simply dropped the plus minus when you dropped the absolute value bars, you would end up with the right answer. But I wanted you to understand why that's the right answer, so that you wouldn't get stuck on that in the future.